Today we're going to take a look at finding the maximum volume of an open-top box, and I'm going to use Desmos to help us solve this question. I am writing this question as a help for my MyOpenMath homework, but I'm sure it shows up in other systems as well. Here's our question. An open box, where the top is open, is made from a rectangular material of dimensions, in this case A is 8 and B is 6. And we're making the box by cutting a square of side X from each corner and turning up the side. And you can see the diagram so you can get a picture of what that looks like. We want to determine the value of X that will give the box a maximum volume. So the first thing I want to think about here is how do we find the volume of the box? And we do length with height. Length is the long side, width then is the other side, and then height is the vertical part of the box. So originally the length was A, our long side, but we've cut a part out. So we don't have this part that was X, we don't have this part that was X. So what's left is A minus X minus X. So it's A minus 2X. Same thing happens here when I'm looking at the width B. It used to be B, but now I took away X and now I took away X, so it's B minus 2X. We have values for A and B. A was 8, so I have 8 minus 2X. B was 6, I have 6 minus 2X. And then that height is just going to be X. So when we go to express our volume, we're going to have 8 minus 2X. Then we're going to have 6 minus 2X. And then we're going to have X. That'll show us how high we were. Second question says, determine the upper limit of the domain of the function v. So let's think about the domain of v. When I look at it, I have to think about this x, and x is a measurement, so that measurement needs to be positive. So it needs to be greater than 0, right? We can't have anything less than 0 because then I wouldn't have a height. Then I need to consider what happens when I subtract this 2x from the length and the width. So I have to think, what's the most I can subtract? Really, this works out to just finding our x-intercepts of this polynomial that we formed from 8 minus 2x times 6 minus 2x times x. So to show you, I'm going to go to Desmos. So you can see this polynomial that was formed, and I have intercept 0, 0, I have 3, 0, and I have 4, 0. Now, the maximum is going to be 3, because do you see over here at 4, between 3 and 4, I have this negative piece, and I can't have a negative volume. So I'm going to be a little fancy and I'm going to show you on Desmos what I would do. I'm going to restrict the domain and I'm going to say, let's make the domain go from 0 to 3. So what this does is it gives me positive values for the volume. I don't want to have a negative volume. That doesn't make any sense. And when we talk about application, we want to make sure we're thinking about what would really work in the real world. So the only thing that would work would be values of x that are between 0 and 3. So I can see I have a portion of the polynomial left, but I can't see the highest point, which is really what I want. So I'm going to zoom in to show you. As I zoom in, it gets kind of hard to see, so I'm going to change my settings just a little. Let's make the x be positive. Let's make this other part be small, because we said we only need to go to 3. I can step by 1. And then the y value, we said, needs to be positive. And now you can see it looks like it goes up to about 25, so let's put 25 in, and we can step by 5. This picture really nicely shows me my lower and upper limit for the volume. So let's go back to our problem and let's put in 3. The next part says find the maximum volume, and then part 4 says what's the value of x. So this is where Desmos is really going to help you. When I go over here, all I'm going to do is click. So when I click, it shows me this highest value. Now let's talk about interpretation. X is the first coordinate, so that 1.131, that's the value of x. That's what I'm cutting out from each corner. Then the 24.258, that is the volume. So the maximum volume will be 24.258 when I have a value of 1.131 for x. So this is answering both of my other parts of the question. So make sure you put in the right thing with the right box. So 24.258. There's my volume. And then my value of x, 1.131. And then as always, we submit to check our work.